In this recording, we'll try to find an expression for the electrical field between the plates of a parallel plate capacitor. Okay, so we have a capacitor here with the positive charges on the left and the negative charges on the right. We label this plate A and this plate B. They are separated by a distance d, and there is a uniform electric field between them, E. And we are trying to find E. So for doing that, consider a positive charge that we are going to move from A, where the electrical potential is VA, to point B, where the electrical potential is VB. Okay, now just before going through with that, remember the potential near positive charges is positive, and near negative charges it is negative. So actually we are going downhill here from A to B. We are going downhill. The potential is decreasing. Now, what's the work done by the electrical force to move the charge from A to B? Okay, to find the work done by the electrical force, we need to figure out the electrical force. What's the direction of the electrical force? The electrical force is given F is QE. Since my charge is positive, F and E are in the same direction, so my electrical force is pointing in this direction. And my displacement is in that direction, so the work is just F, which is QE, times D. The change in electrical potential energy is just the negative of the work done by the electrical force, or minus QED. Now, what would be the change, if this is the change in electrical potential energy for the charge, what would be the change in voltage, delta V, between point A and point B? The change, we can relate it to the electrical potential energies through the expression relating electrical potential energy to voltage. So for that particular charge, it's Q times delta V. So consequently, we can write delta U is Q times delta V. So solving for E, I have, actually I'm solving here for the voltage difference. The voltage difference between A and B is equal to E times D. Now remember, the voltage is higher at A, so VA minus VB is plus E times D. I'm not sure why I wrote the 0 here. It's not meant to be. It's the electrical field between the plates. Or E is equal to the voltage across the capacitor over D. Okay, I did this analysis with a positive charge. I do it here with a negative charge. Okay, so we are going to do the same thing, but we are going to take the negative charge from A, where the potential is high, to B, where the potential is low. The difference here is my electrical force is in this direction, which means that the work done by the force is going to oppose the displacement, so it's the magnitude of the force times D with a minus sign, minus QE times D, which means that the change in electrical potential energy is going to be positive in this case. And writing the same thing, that the change in electrical potential energy is Q times the change in voltage, so we get this. However, here Q is negative. Okay, remembering that, what that leads us, since Q is negative, this is effectively minus the absolute value of Q times VB minus VA. So when we write the equal sign, we still have the same issue like last time. We end up having the same expression, where VA minus VB is E times D, or the voltage across the capacitor is E times D. Again, I didn't mean to have that here.